Number 15 on page 149 is another problem that you probably need to graph the original in order to be able to graph the reciprocal. The reciprocal of 1 over x squared would have been y equals x squared. So let's see if we can graph that. Hopefully you remember that y equals x squared is simply a parabola that starts at the origin and obviously graphs up in this general direction. And of course, because it is symmetric about the y-axis, it looks like that on both sides. Now, this is not a perfect graph, but it's close. You can see we hit the right points. So let's remember our three rules for graphing a reciprocal. Y equals 1 stays the same. Same thing with y equals -1. The zeros become asymptotes, and the asymptotes become zeros. And then where it gets closer to 0, the original graph, the reciprocal will flee 0, and vice versa. So let's look and see if we have any of those situations. First of all, you'll notice that in our original function of y equals x squared, we do have a couple of 1s that are right here and right here. Those 1s will stay the same. You'll notice that we also have a 0 in our original function right here. That 0 now will become an asymptote. And now we just need to look at it and see where is the original graph getting closer to 0 and where is it fleeing 0. You may notice that as it moves toward the asymptote, it is getting closer to 0 in the original, so our new one is going to flee 0 at those points. Of course, we're talking about the y values. And as it's moving away from the asymptote, it is fleeing 0, so our new graph is going to be there. So our new graph is going to be this green function, y equals 1 over x squared. Once again, this is one of those where you really need to graph the original in order to get the reciprocal. On number 16, although you could graph the original of y equals 3x minus 4 and then go through the process of going through these rules, I don't think that's as necessary in this one because we're just going to start by finding where the denominator equals 0. And where the denominator equals 0, of course, will be a vertical asymptote. So we're going to start just by taking that denominator, 3x minus 4, setting it equal to 0. Move the 4 to the other side, and you get 3x equals 4, and of course now x equals 4/3. That means 4/3 is an asymptote. Now, of course, that's somewhere right in here. Once again, these graphs don't have to be 100% perfect, but we do want to make them as accurate as we can. So that will be an asymptote. And from here, we can just look at it and realize this original function would have been a linear function, and this new function, the new reciprocal function, 1 over 3x minus 4, is a positive function, which means on the right side of the graph, it needs to stay positive. Of course, we have a vertical asymptote and a horizontal asymptote, so there's really only one thing this graph can do within that region, and that is get closer to the vertical asymptote and closer to the horizontal asymptote. On the left side, remember when it crosses a vertical asymptote, it goes to the other side. So on the left side, it's really left with only one option there as well. So I graphed this one instead of graphing 3x minus 4 and then trying to figure out closer to 0, farther away from 0, y is staying the same. This one I just used some simple logic. I found my vertical asymptote, and then I realized it can't cross the vertical or horizontal asymptotes, and so I just used some logic to trace in roughly where this one is going to go.